Hello and welcome to my presentation. I'm going to be going over static testing in the cloud. Pretty much how do we apply modern software static testing suites in cloud infrastructure. And I think this will be quite relevant because of the explosion of growth in cloud technology and the fact that wherever you as an individual might be working, you'll probably be working alongside teams which are responsible for making and getting the work that you're doing into an online environment. And knowing how things are being tested or things are being configured can be very useful in how you're designing, your own application or whatever you plan on doing. So let's just move forward with um, you know, first off, what is an understanding of like the cloud? Oh, I'm a developer. What exactly do I care about this? And so, primarily the cloud infrastructure has always been on premises prior to there being anything that existed in the cloud. So you'd think of like Microsoft Outlook server. They would provide all of the application information, the data that's running on it. You would install an on-premises server that you'd have to install Windows Server 2012 or 2016 on, and you set up all of that infrastructure on your own within your own business in order to provide that service to all of your end users. And it's with the advent of cloud technology, um, there were, for instance, like software that was being delivered directly. You think of Dropbox. You don't need to do anything. Your files just live in the cloud. You can access them through multiple different devices. There's nothing that you need to do as an individual. Or you could think of platforms as a service, something like Heroku or Amazon's Elastic Beanstalk instance. Those are both great options where you can design an application that runs well on Windows or runs well on Linux, and you don't have to worry about, scaling and scalability and other types of things. Um, these platforms will just do all of the security and the backend stuff for you. Your application just needs to be built and have a purpose, and you can sell it. And then there is infrastructure as a service, which is where I'm going to focus this talk on today, because infrastructure as a service is where businesses are moving to. You get the cost saving of working with large warehouses of computer technology, and that cost saving comes from mass purchasing, and then you don't have to spend all of this IT work on doing your own server networking and data management, and you can just build your application, make it secure, control all the endpoints. If you want to add on, specific Docker containers and small other plugins, you can do that. And so that's where infrastructure as a service has really shined, and businesses tend to be moving. Even legacy businesses, which were primarily on premise, are looking at infrastructure as a service as part of their goals in 2020s. So cloud infrastructure consists of a couple different types of services. So you'd have, very popular services like, oh, I need a database. I need somewhere to keep all my information. It's going to be a SQL database. It's going to be a NoSQL database. Doesn't really matter. Every single cloud provider offers that. Also, they typically offer some method of running computer power, right? You have virtual machines, whether it's the Amazon machine image or some sort of um, Ubuntu-based backing virtual machine that's running through Azure. You can easily get access to that. You have networking, such as like setting and scoping your DNS settings, restricting traffic through firewall or IP restrictions, and you also have user rights. So everyone only has access to what they need, or services only have access to very specifically scoped uh, parts of that cloud infrastructure. And that's just very common and popular ways of interacting with cloud infrastructure. So then you get into a little bit deeper um, ways of using cloud infrastructure, such as running continuous analytics and monitoring. I want to know everyone who accesses my site, where they click on, where they go, what's my hit rates. You can get those with other tools as well, but it's kind of built into cloud infrastructure. You have the benefit of a multinational um, server farm. You can do content delivery all across the globe with reduced latency. You have all of these like specific computer technologies that are um, focusing on caching, so that your user, if they've gone to your site before, or if they're accessing something through the cloud that they've accessed in the past, it probably can be sped up much faster than them having to download it every single time. And there's also integration points with continuous deployment. I can use my cloud infrastructure to push an application and some other content through a continuous deployment pipeline, and be very confident that my application is doing what it's supposed to, and it's going to work in the environment that I plan on running it in production. And then lastly, you have uncommon uses of cloud infrastructure, such as, oh, I want to interact with mobile devices in a very specific way, or I want to work with enterprise level application services, like Amazon Workspace or something like that. You have workflows, business workflow that might need to be there, or you also have archiving services such as Amazon Glacier, or if you run a large WordPress site, you might want to archive old posts that are getting very low hit rates. So these are all types of things that every cloud infrastructure player has on the market, and you can use them. Another thing that you might note is there's a couple names that everyone knows in the market, and that's Amazon Web Services, that's Microsoft Azure, and Google Cloud. And there's a couple other ones as well. And one thing that's really neat, much more than what percentage of the market each of them holds, is the fact that year over year they've been growing, and every business that does cloud has been growing and growing quickly. And I don't think this trend is going to stop anytime soon with the pandemic that's been going on. And so knowing about cloud technology, how it works, is going to be key for any type of developer doing work in modern businesses. So what am I touching on today? I'm touching on infrastructure, which is going to be part of the applications of the future, and how do we manage it? How do we test it? And that's where infrastructure as a code comes in. So infrastructure as a code is pretty much the idea that I can describe the things that are my hardware, that are my backing support for my application, for the code that I write, uh, and I can describe that through code and then reliably bring it back online. Or I can publish a new version and know that it's going to be the exact same as the previous version because there's no change to my configuration. So an infrastructure as code tool is technically just a reproducible configurator tool. It takes a configuration and it describes it in its entirety. And I have a couple points here. First off is it's often platform agnostic, which means it doesn't have to be tied to a very specific cloud provider. You could describe an Amazon instance, but you could also describe an Azure instance, and you could deploy your application to both simultaneously. And that would be a fault-tolerant way of making sure that your application doesn't go down if somehow Microsoft goes bankrupt. And another thing is it's a templating language. So a templating language is very useful because you can use um, one file to describe small variations in your configuration changes. Like, oh, I want to point to a SQL database, but I also want to point to 3 SQL databases for this specific use case. I can set that up through templating so that it's just, an environment variable that is configured, and it will slightly change the actual implementation of that infrastructure. And so the last thing to note is that infrastructure as code breaks very significantly from regular coding terminology in that instead of it being imperative or running sequentially, it's declarative. So there's some sort of backing engine that looks at the configuration that you provide and then makes a decision about every single point. And so typically you would have like a JSON or a YAML style file, which has a bunch of key value pairs that are grouped, and those describe the infrastructure resources that you want to create or modify or upgrade. And so this is just a very simple example on the side. I'm using AWS provider, which means give me all of the resources and the things from AWS, and I want to create a what's called an EC2 or a virtual machine that is able to run some code, and the backing engine would just go ahead and create that information. It would create those infrastructure points. So declarative code is different because there's a bit further depth to it. And so this is where testing becomes a bit more tricky. So we run into this challenge where the introduction of DevOps is really like we do our development, and while we're doing development, we make sure that we're deploying it and it's getting into our replicate of our production environment. We're checking that out, and anything that goes a little funny in that environment comes back, and we can fix it on the fly, right? And when we fix it on the fly, we push it back, and we verify that it's been fixed, and we just continuously iterate through this system. So the tricky part, though, is in your development, you still want to be doing testing. You want to make sure that you have tests which are able to be run, which validate the the intent of your code base. And with infrastructure as code, you can't because it's not really there until you actually go and apply it. And once you go and apply it, if there's a failure, that means your system is not working. And so the ability to actually test it kind of needs to be worked into this continuous integration. And so there's some ways of trying to approach this problem, but ultimately you can't be 100% confident that what you're coding is going to work because it's just not something you can actually do while you're developing. And so the hope is, we can get closer and closer to this, and we can also provide some analysis tools that provide, useful information during development to developers about the environment that they're actually going to be deploying in. For instance, if I'm a developer, I'm saying, hey, this is a really cool, third-party application. I want to integrate it into into our tool set. It looks great. Um, and then I take that tool, I add it in, it works locally on my system, and I push it into the pipeline. And nobody realizes that, there's some security risk because it needs to expose a specific port or something like that. And so, there's tools that come in that would look over like any type of infrastructure change that's required to support your application and can make recommendations based on um, what's actually there, and what is best practice. So let's talk about the infrastructure as code analysis. So obviously, what we're focusing on here is static analysis, such as code validation, looking at like whether your configuration template that you describe is complete or not. Is it missing content? Is there a security risk that is an inherent part of what you just tried to describe? Or, is there missing dependencies? Can I, describe all of the infrastructure, but are you missing something? Is there like a DNS entry that needs to be created that you just forgot to describe, and your whole system's just going to fail when you try to go and apply it. And then there's your dynamic analysis that says, oh, like as soon as I create this stuff, run some real-time security scans, ping a bunch of ports, tell me if stuff is getting through where it shouldn't. There's also resource performance monitoring, like, are my systems overloading? Are they shutting down because they can't handle load? There's fuzz testing, throw a bunch of junk at your application and see if, your infrastructure can handle it. And then there's the last thing, which is, running continuous compliance policy checks that say, hey, is my infrastructure compliant with what we expect? And or has it drifted over time due to small changes that are going on? So again, we're going to focus on static analysis just because static analysis is fast. You can run it locally. You can run it as part of a continuous integration pipeline, and um, it's it's not as powerful as certain dynamic things, but it can definitely be of a huge use when it's part of your development cycle. So the first generic type of static analysis is linting. Linting is already done probably in every programming language that exists, and it can be extended into infrastructure as code as well. So, for example, if your configuration is, a YAML file, it's relatively straightforward to go and say, hey, I want to describe what is the proper configuration of the YAML file. Is there anything wrong with my file? Or, if you're using other type of infrastructure as code tools such as Puppet or Chef or Terraform, there are tools which perform style guide checks against all of the code to make sure that you're not putting things in which aren't going to work, and you get that immediate feedback, and that's just a type of static analysis. Then we get into a bit more intricate types of tools, such as TFSec or Terraform Security. And this is a type of static application security testing, which will look over your configuration that you've designed, and it pulls in a library of best practices rules that say, hey, like what's going on? Um, Here's a suggestion. You probably shouldn't have your security group open to every single IP in the world. Maybe you should restrict it to only the IPs that you're expecting. Um, so that's a sample of security rules. And then the last is you can actually have uh, code-based policy checking. There's a great tool called the Open Policy Agent, and this is something you can actually put in during part of your CI. And so it doesn't need to run against your infrastructure that's already created. You can also use it to check, are people trying to build infrastructure that is going to fail the policy, and catch that even before they push it into some sort of environment. Oh, they're trying to pull from an untrusted registry of Docker images because, it's open to the public. People have, supply chain attacks that have worked against that type of provider. And so those are the types of things that modern static analysis tools can do. There's a bunch of research which is currently going on, which I go into more detail in my project report. Um, and that is dealing with, can you, for instance, create a directed acyclical graph of all of the infrastructure resources and look and build the dependencies between them and segregate them. And anytime that you make a change, you introduce a new resource, you remove a resource, you change the sizes of things, you could rebuild that graph and look at the difference and then actually recompute it to see um, if it will resolve in an error or or in a valid configuration. And so those are the types of things that are being explored in academia, but tools for that do not yet exist because it's beyond the scope of you know modern modern development. So I'm just going to run a quick demo just to describe what exactly these tools kind of look like live and how you can interact with them. So this is my example. I'm running Terraform, which is an infrastructure as code tool. And this is a very straightforward uh, Terraform file, main.tf. I just have it in a Windows subsystems for Linux virtual machine running on my Windows. You can see it pulls in a Docker provider, and that Docker provider refers to a specific image, which is an Nginx image. Nginx is a proxy, one of the most popular and most stable proxies online. And I'm just going to create a Docker container. So let's run Terraform init so that we pull in information, and then we can run what's called the Terraform plan. And so what this does is it tells us what it's going to do. So it says, hey, if you run me, I'm going to go and try to create this resource. I'm going to try and, build it with, the content that you've specified. All of these information could also be overwritten or specified. And I'm going to create a second image, which, points to Nginx latest. And if I choose to apply it, Terraform apply, then it repeats this information and asks, do I want to go ahead and do that? If I click yes, then it's going to go ahead and create that Docker configuration. And so I didn't need to create a Docker file. I didn't need to do anything crazy, but I now have, if I open my Docker desktop, just give me a second. Let's see what containers I have running. I now have tutorial running, which is running on port 8000. And let's give it a quick open, and I have an Nginx container running on my local system. And I didn't have to run any Docker commands. So that's just an example of using Terraform to create an infrastructure locally. And if I want to take it down, I can just, remove it. Oh, sorry. Destroy. Again, it prompts to whether or not I really want to go ahead and destroy it. And now you can see it's no longer running in my Docker desktop. You'll also notice that it created this tf-state file. That's basically a way for Terraform to track what the state of this entire system is in. So it would right now be probably blank. Let's see if I just open it to the side here. Yeah, so it pretty much says, hey, there's really nothing here. And and it just tells me what version of Terraform was run against this resource. But if I did have these still created, they would be described in here as well, so that if I were to make a change and try to update it, then it would just pull the state and compare it to the change that I made. So I'm going to go in and say, okay, like infrastructure as code, pretty cool. But what about static analysis tests? what can we do with those? And for that, I'm just going to go to my demo directory, which is a Git repository pointed at Azure. And so I'm just in the master branch. It doesn't have anything. I can see that there's these 3 files, but they're not even committed. They don't exist yet. So there's this really cool tool called pre-commit, and that's what I wanted to demonstrate today. It's able to run a bunch of like hooks. So anytime that you try to make a commit, you can basically say, hey, run a whole suite of tests against the changes that I'm committing, and then I'm gonna, if something's wrong, then don't commit my information. Let me fix it, and then let me try again. So it's a pretty neat local development tool that allows you to run an entire suite of validation and static analysis tests against any change that you're making, and it's very fast. And I'm just going to demonstrate it here. So I'm just going to quickly pre-commit. I want to know if I'll need to make a configuration file. So sample config to now I have a pre-commit config.yaml file. This is just the basic one. So if we commit all this stuff, git add, we can see everything is now ready to be committed. And if I run pre-commit run, it says, hey, everything looks pretty good. There wasn't anything wrong. But I could also, I could make a mistake, and then, oh, there is an error in my YAML file. This indentation indicates that there's a something off with line number 9. So I'm gonna do something about that. Fix it up, add it back. So again, you can see like it will run these types of checks. But what we're more interested in is actually what are all the other types of checks we can run, not just the basic ones. And so there's this great list at precommit.com of every single type of pre-commit supported tool. So you have a lot of Python stuff, you have PHP and Ruby checks, but what is pretty neat is we also have infrastructure as code checks that we can run. So for instance, there's a whole section on Terraform related commits. And so I'm just going to quickly install one of those now. So I've already prepared a little demo one just called tflint. So this is a linting tool that can run certain commands. And so I'm also going to just enable this specific rule in the tflint so that I can demonstrate it to you guys. And this is the Terraform documented outputs. Make sure that anytime that I output information, it has documentation to it. And you can see right now that all my files have been added, but I'm going to just re-add my pre-commit config now that I've made this change. Run pre-commit run, and you'll see, oh, there was 2 issues. My pre-commit config.yaml needed an end of file fixer, so it added a space here, and it fixed this for me. And it gave me a warning, hey, lbdns name has no description. My outputs need to be documented. So let's give it a description. Load balancer output name. And then we'll re-add, git add. We also need to re-add our YAML file. Run pre-commit. Now everything's passing. It's happy. So this is neat. But what we're more interested in is tools which don't just look at my configuration, don't just do like style guide checking, but which actually tell me useful information that I can make changes to. Um, so before I get into any more depth, let's just see what this is trying to accomplish. So it looks like I'm in AWS. I'm trying to launch EC2 instances and also set up an auto scaling group and a security group. And it looks like there's a load balancer behind that too, with a couple listeners on an HTTP port. So this is a basic, you know, VM that I would be spinning up that has a scaling group to it. I think the scaling is a specific size. Yeah, looks like it'll have a size of 2, and if the load on the scaling group hits a certain pre-configured criteria, then it'll just keep adding more to it until it hits a max size of 10. So, it's a pretty robust uh, application that I'm going to build if I run this. So the first thing I want to do is actually run it. So let's just do, obviously, in order to run, if I just run, for instance, Terraform init in my demo, it'll go ahead and it'll say, hey, I made some stuff. I created a Terraform directory. It looks like I'm initialized, but if I run Terraform plan, it doesn't have any credentials, right? It needs to know what AWS infrastructure it's pointing to. So for that, I have configured AWS Vault to run a specific as a specific user, which does have access to EC2. And from that, I can actually go ahead and hit AWS. So um, it's run a plan, and it's saying, hey, you can go ahead, you can create this. It'll create a security group. It'll create your launch configuration. It'll create a load balancer, and it'll create an auto scaling group. Great, I can make this. Looks good. But is it actually good? I want to know that. And so this is where we're going to come in, and we're going to add a hook that runs a security scanner. And this security scanner tells you, does your code pass, some preset rules? So let's update this. Add make sure it's there. I guess it added all the lock files and stuff. That's fine. It's not going to do anything. I'm not actually committing it. So let's rerun our. But we knew our plan was good. Nothing's changed there. But let's rerun our pre-commit. What it tells us. So that was pretty fast. It ran over our infrastructure. Couple milliseconds, and it gave us 5 warnings. Critical. Our security group defines a fully open IP block. Port is exposed. Set a more restrictive range. Right? Oh, this is great information. If I run this consistently and I need to clear all these messages out, then I'm going to be a bit more confident that the infrastructure that I'm building is actually secure. And each of these has other suggestions to how you can make your system as secure as possible. And so part of my project was looking into this open source repository, and uh, there are open requests to continue to extend the rule set that's available to TF security, and it's being used by hundreds of companies around the globe as they adopt infrastructure as code and work at migrating all of their security critical applications into the cloud. So I think that there's a lot of value that's available um, and visible through having these types of tools in your cloud infrastructure pipelines, and even if this is not something that you personally touch, being aware, being responsible, being able to make suggestions to your team, to whoever you're going to be working with about cloud infrastructure security, about cloud infrastructure reliability, is going to be very key in you know your in your role and your responsibility in developing secure and fault tolerant applications. So thank you for your time today, and I hope you learned a bit about declarative infrastructure as code. Have a great day. Bye bye.